going to take you through some examples of derivatives of polynomials, including powers of polynomials. We're going to be using the power rule as we go through these. Let's go ahead and jump into this first example. In this first one, I've got the derivative with respect to x, that's my variable, 2x cubed plus 5x squared minus 7. As I take this, I'm going to go ahead and do it term by term. So first with the 2x cubed, I pull the 2 out in front, it's a constant multiplier, and then we're going to take the derivative of x cubed. Power rule, 3 goes out in front, and I subtract 1 from the power. I'm going to squish it in right there. Let's go ahead and do the next one. So plus. Next, we're going to do the 5x squared. The 5 comes out in front. Power rule here, 2x, so 2 comes out in front, 2 minus 1. And then finally the derivative of the 7. Let's bring that negative sign down. The derivative of any constant is 0. If I simplify what we've got, I've got 2 times 3, which is 6. That was an x to the 3 minus 1, which is equal to 2. And now 5 times 2 is 10, so I get 10. And then 2 minus 1 is 1, so I get 10x to the first. Or you can just more simply write that as 6x squared plus 10x. Next, let's take a look at a power of a polynomial. In this next one, I've got 5 times the quantity 2x plus 1 squared. Before I do anything, I need to expand that 2x plus 1. So I'm going to hang on to the ddx. I'm not applying my derivative yet. And I'm also going to hang on to that constant multiplier 5. Let's go ahead and rewrite our 2x plus 1 squared as 2x plus 1 times itself, 2x plus 1. Next, we are going to FOIL these two guys together. Again, I have not applied my derivative. I'm going to do that at the very, very end. A lot more algebra than calculus goes into this. Okay, so multiplying this out, 2x times 2x, that's going to be a 4x squared. Again, I'm just using FOIL. And then outer is a 2x, inner is another 2x, so that gives me plus 4x. And then on the end, I've got 1 times 1, which is plus 1. I'm going to continue to simplify. Let's bring that 5 through. The more simplifying I can do in the beginning, the easier my derivative is at the end. So now I've got still the derivative out in front. I'm going to bring that 5 through, and I get 5 times 4, so that's going to be 20x squared, plus another 5 times 4, that's 20x. 5 times 1 is 5. I'm finally ready to apply that derivative. Let's give ourselves just a little more room here, and we're ready to finish this one off. So applying my derivative, I'm going to start with the derivative of 20x squared. The 20 is out in front as a constant multiplier, and then I'm going to take the derivative of the x squared. 2 comes out in front, and I get x to the 2 minus 1, applying that power rule. Next, 20x. So that's going to be plus, the 20 comes out in front, and the derivative of x is just 1. Finally, the derivative of 5, any constant, the derivative is equal to 0. I can clean this up a tiny bit, and I get 40 x to the first plus 20. And that is our answer. Let's move on to the next one. In this next one, I've got 2 different polynomials multiplied together. Now our theme here is to simplify and expand. I want a single polynomial so I can differentiate term by term. So before I do anything else to this one, let me go ahead and just bring the ddx down because I'm not ready to keep going. I am going to use FOIL. So let's go ahead and move through the FOIL. X squared times 2x, that's going to be 2x cubed. Outer is a negative 5x squared. Inner is plus 6x. And then finally, last 3 times 5 is that minus 15. Now I've got a single polynomial, and I'm ready to differentiate term by term. Applying that derivative, I can take the derivative of 2x cubed, that's going to be 2, differentiating the x cubed. 3 comes out in front. X to the 3 minus 1 is going to be 2, applying that power rule, kind of squishing it in there. I'm going to do the same thing. I'm bringing the minus 5 down, differentiating the x squared. That's going to give me 2x to the first, and then differentiating the plus 6x. The 6 comes down, the derivative of x is equal to 1, and then the derivative of 15 is equal to 0, again, any constant. Let's simplify what we can. This is going to be our answer. 2 times 3 is 6, so I get 6x squared. 5 times 2 minus 10x plus 6, and that's our answer. I've got one more for you. In this next one, I have a division of polynomials, that trinomial divided by the 3x squared. I'm going to simplify and get a single polynomial, and I can do that because I have a monomial, a single term in the denominator. I'm going to divide each term on top by the 3x squared. So bringing the d dx down, let's go ahead and work through this trinomial and divide each term. So I'm going to take the 12x to the fourth. I'm going to actually write each of these in a numerator. That's going to be divided by the 3x squared. And then minus the 6x cubed, which is also going to be divided by the 3x squared, just splitting this up amongst that numerator. And then finally, the x squared divided by the 3x squared. Because I've done this, I can go ahead and simplify by canceling. Let's move through and cancel what we can here. So the x squared cancels with the x to the fourth. There were 4 of those. It leaves me with 2. X cubed, there are 3 of the x's. I'm going to cancel 2 of those, so I'm left with a single x there. And then the x cubes completely cancel. Let's take a look at what our polynomial looks like now. So I've got d dx. And then inside of my parentheses, I've got this nice polynomial. I've got the 12 divided by 3, that's equal to 4. And then I have an x squared left, x squared. Minus 6 divided by 3, that's going to be a 2. And I've got an x to the first left. And over here in this last term, I just have the 3 in the denominator. So I'm going to write that as plus 1 divided by 3. I'm ready, since I've got this nice simple polynomial, to take the derivative term by term. Okay, here we go. So let's go ahead and do this derivative. So 4, I'm going to take the derivative of x squared, which is 2x, or 2x to the first, minus 2. The derivative of x is equal to 1. And then finally, the derivative of 1/3 is 0. If I simplify this, just multiplying what I can, I get 8x minus 2, and that's our answer. In my next video, I'm going to show you some derivative rules that you need to know, that you've got to have memorized. Take a look at that video next, along with my other videos. You can do this. It's going to take some practice, but I know you've got it. Thank you so much for watching.